Today's my lecture topic is radiation. This is the most important heat transfer mode, or one of the three important modes of heat transfer is radiation. Radiation is one of the three fundamental modes of heat transfer. It involves the emission of electromagnetic waves due to the temperature of your body. It does not require any medium. It can occur in vacuum. For example, from sun to earth. All objects above absolute zero emit thermal radiation. Radiation transfer depends on the surface temperature and the properties. The mechanism includes heat is emitted in the form of electromagnetic waves, primarily infrared. The higher the temperature, the higher the intensity and the shorter the wavelength of radiation. Radiation can be absorbed, reflected or transmitted by the surfaces. The net radiation exchange depends on the temperature difference and emissivity. Radiation travels at the speed of light. This is an important one because light travels at a very high speed. In radiation, another important concept is blackbody concept. The blackbody is an ideal surface that absorbs all incident radiation. It also emits the maximum possible radiation at a given temperature. Real surfaces emit less than black bodies and are termed gray bodies. Blackbody radiation provides a reference for comparing real material behavior. Planck's law describes the spectral distribution of blackbody radiation. Next one is laws governing radiation. What are the laws means? The important laws is Stefan-Boltzmann Law. That is E equal to sigma T power 4 into E. That is where E is the radiant energy emitted, sigma is the Stefan-Boltzmann constant, T is the absolute temperature. Next one is Wien's displacement law and Kirchhoff law, the Planck's law. These are the three laws associated with the radiation. Kirchhoff law is at a thermal equilibrium, emissivity equals absorptivity. This is the Kirchhoff law. Radiation increases rapidly with the temperature, that is to the fourth power. That is the radiation increase in the surface properties includes emissivity E. Emissivity E measures of a surface ability to emit radiation. Emissivity ranges from 0 to 1. Absorptivity, fraction of incident radiation absorbed by a surface. Reflectivity, fraction of incident radiation reflected. Transmissivity, fraction of incident radiation transmitted. This is called the transmissivity. Next one is radiative heat exchange. No heat exchange between two surfaces depends on their temperatures and emissivities. Radiation exchange can occur between enclosed surfaces or open surfaces. View factor determines how much radiation from one surface reaches another. Radiative heat transfer is a non-linear process. Radiative exchange between surfaces is influenced by geometry and orientation. Radiation in gases. Gases like CO2, H2O, vapor and emit absorb radiation. Radiation plays a key role in combustion and atmospheric heat transfer. Transparent gases do not absorb radiation as well. Participating media absorb, emit and possibly scatter. Next one is applications of radiation. Solar radiation powers photovoltaic and thermal system. Infrared heaters use radiation for space or industrial heating. Thermal imaging detects radiation for temperature mapping. Used in spacecraft to manage thermal loads in vacuum. Furnaces and kilns rely heavily on radiative heat transfer. Thermal insulation often minimizes radiation losses using reflective coatings. In engineering consideration, highly polished or shiny surfaces reflect more radiation. Blackened or rough surfaces emit and absorb more radiation. Radiation shielding and multi-layer insulation are used in high temperature application. Heat transfer by radiation become dominant at high temperatures. In HVAC system, radiation is considered in comfort and building design. Modeling and analysis. Radiation is modeled using surface properties and energy balance. Complex problems involve combining conduction, convection and radiation. This is a complex problem. Radiation network analysis helps in enclosed space calculation. Computation methods like ray tracing and more Radiation analysis is essential in fields like thermal engineering, astronomy, and climate science. Thank you.